Hi everyone, I'm delighted to walk you through a recent work where we investigate how much references are important for machine translation evaluation. Specifically, we'll look into how many references we need and of what quality. In order to study the effect of references, we first need to get some basics down. In machine translation, we have the source sentences. We pass them to the system and get the translations. In order to find out if the system on the left is better than the system on the right, we can ask humans. There are many annotation protocols, but conceptually, the translators read the source, the translation, and assign a number. Alas, humans are not perfect, make mistakes, and are inconsistent. One day you might rate the left translation better, but maybe not another day. Also, they are super difficult to use at scale. In research, we usually need to evaluate multiple model versions on millions of sentences, and that's simply intractable. For that reason, we create automatic metrics. They are functions or models that also read the translation and produce a number on some scale. Importantly, the metrics are designed such that they correlate with the human judgment in ideal circumstances. The machine translation community developed many metrics. The most infamous one is the BLA metric, which compares n-grams between the translation and reference translation, which we consider to be perfect. In fact, most metrics are reference-based, which begs the question how sensitive they are to the references and if we can improve the evaluation by having better references. For an example, consider this translation from German, Ich verstehe nur Bahnhof, which is a phrase that means to not understand anything. The reference translation is, however, incorrect and is too literal. The translation that we want to evaluate is also too literal and incorrect. The final translation score is minus 0.986. If instead we try to evaluate a better translation that has the correct meaning of not understanding anything, we get a worse score. This is exactly something that we don't want to happen, because we want better translations to have higher scores. The culprit here is the reference translation, which was bad to begin with. Now, why investigate the effect of references? I hope that I convince you that references possibly matter in a segment-level evaluation. Now imagine that you're a shared task organizer and gave a bunch of teams sentences to translate. The teams do their best and give you back the translations. And you don't have the budget to annotate all the translations, so you want to use some automated metrics. And for that, you need to get reference translations. Maybe you're in contact with multiple vendors that can provide the human translations. Different vendors have different costs, and maybe the first one is super cheap, but also has mistakes in the translations, while the last one is super expensive, but also provides impeccable translation quality. Now, which one should you choose to get your translation? That is the focus of our research. We are slowly getting to the results, but the last stop is the data setup that we have. For each source sentence, we have multiple translations of varying quality, and in addition, each reference is further post-edited by a worker ranging from students to professional translators. At the same time, we have all the system translations from the WMT shared tasks and their human evaluations. The task that we try to optimize is reference-based metric performance, which we measure by correlation with the human scores. And of course, there is more to do with this data, which is why we made them easily accessible. We have 4 human references for each translation, with R1 being the lowest quality and R4 being from the translatologists, so super high quality. In this table, we compute the metric scores with the different references and compute the correlations with human judgments. And indeed, there is a trend that the better the reference quality, the higher the correlations. However, the reference R4 is special and doesn't lead to the best metric correlation. One of the reasons is that very high quality translations have something called a translation shift. To illustrate, when translating a book, one cannot just translate each sentence well, but needs to also modify the text so that it flows well in the target language. With translation shifts, however, the translation deviates from the original, which causes discrepancies in evaluation. Still, the effect of reference translation quality is an important one that applies to all metrics. For Comey, using the worst reference is almost as bad as not having the reference at all in the quality estimation model. Another problem is that while the references might be of high quality, the system translation evaluation is done by skilled but still crowd workers. In this plot are 11 annotators. 4 are professional translators, 3 are translatology students, and 4 are layman crowd workers. Their task is to rate a whole set of translations by a system. Clearly, based on their expertise level, the annotators produce much different distributions of scores. For example, the layman crowd workers are much more positive than professional translators who scrutinize the outputs more. This is one of the reasons why the superhuman references aren't the best for evaluation, because the system evaluation is done by translators and not academic translatologists. Recall that we have 4 references of various qualities, but in addition, each reference is further post-edited by either a layman, student, or a professional. Assuming that post-editing does not worsen the translation quality, this should lead to an improvement in segment-level correlations. And indeed, when we look at the difference between the standard reference and its post-edited version, in all but one case, the post-edited version leads to slightly better correlations. Okay, so we know that reference quality impacts evaluation performance. Now let's focus on quantity of the references for a bit. In this case, for each translation, we compare it to possibly multiple references and take either the average or maximum. We start with the best singular reference, R3, and add it to the second best one, R4. Not surprisingly, this improves the correlation. We can take this further. We can compare to all the references, which pushes the correlation even higher. In fact, we have many human references per single source translation, and we can investigate this from a different perspective. If you take a random set, say, of 3 references, what's the correlation going to be? Now, what if you have 7 references or more? In all cases, and for all metrics, adding more references always helps. However, this effect plateaus after having 5 references. This might be because we used up all the translation diversity, and minor differences in translation do not affect the evaluation that much. We can see that string matching metrics such as BLE or character level F-score benefit from this much more than neural metrics such as COME. Now we know that both quality and quantity matter, but how much flexibility do we have in mixing them? When we have multiple references, they very likely come from different translators and also likely from different translation houses. Previously, we explored if we can have multiple references sources per signal sample, but to test the flexibility limits, we now test if some source sentences can have the reference from one vendor and the rest from a different vendor. In this example, the first 30% are from an expensive and high-quality vendor, while the rest is from a cheaper one. And this is important, especially at scale, because translating a large number of sentences is usually not possible with a single vendor. Now there is a reason why this shouldn't work. This is because if we change the reference, we are also changing the absolute score of the metrics. So in our example, the first 30% of segments would have a higher average than the rest, which introduces a bias. And let's see what happens when we evaluate some sentences against the one reference and the rest against another one. This graph seems complicated, but does just this with pairwise mixing. In the first segment, we are mixing between the first reference and the second one. And interestingly, this mixing works almost linearly between the endpoints. Now we know that reference quality and quantity matters, and that we have quite a bit of freedom, but how do we optimize all this on a specific budget? So let's pose that as an optimization problem. We have some certain budget, and we get an offer from a few vendors. Some of the vendors are cheap, but we know produce lousy translations. In contrast, some vendors are higher quality but very pricey. We assume that we have some estimates on these properties, perhaps from our previous interactions. Now, who should we ask to provide us with the references? And should we ask for multiple references or focus on high-quality ones only? We can visualize this in a table. Each column is a source sentence, or document, or whichever unit we operate on. Each row is the particular reference vendor. We start with all source segments being assigned to the cheapest vendor, for which we assume we have the budget. Then, as long as we have the budget, we either promote a segment to be translated only by a higher quality vendor, or by the lower quality and higher quality one at the same time. Now we just repeat this until we reach our budget. Note that in each step we are improving the quality of the evaluation, as per our previous findings, but they also cost more. For the promote action, we move from a cheaper lower quality to more expensive and higher quality vendor. For the add action, we request an additional reference, which costs more but improves the evaluation. And this means that this algorithm is going to terminate. Whether we prefer to have more references or fewer high-quality ones is determined by a hyperparameter lambda. Now let's look at the results. On the x-axis is our budget, from small to high. On the y-axis is the lambda hyperparameter. As expected, with the higher budget, the algorithm selects more references, which happens also when we request them with the higher lambda. What's more interesting are the correlations of the final reference setups found by the algorithm. This is coded with the colors in the tables. For both of these metrics, the best way to allocate the budget depends on what the budget is. If you have a smaller budget, then we should optimize for quality of the samples, but if you have a larger budget, then it should be spent on getting multiple references per each segment. This is the very high-level overview of the simple stochastic algorithm. There are some important limitations that we need to acknowledge. One of them is that this is just a single language pair and just 160 source sentences. The reason for that is that we wanted to have multiple references and each with a second round of post-edits, which limited us on the scale. The main takeaways is that reference quality does matter for machine translation evaluation, and that one should try to get the same level of reference translation quality as the non-existent human evaluators that we wish to skip over. In our case, we had commercial translators as the evaluators, which is the reason why the superhuman translators weren't the best references. For the number of references, the more the better, because we can always just average the segment level scores. Finally, we find that the references from multiple vendors can be mixed together and optimize the best use of the budget. For the future, it's worth looking into the effect of reference quality and quantity on the system level evaluation and on larger scale. We couldn't do that here because of the low number of sentences and systems, but that's still an important application. I'd also be interested in some ways in which to quantify the reference quality, because currently we just use the downstream correlation as an indicator, but that's just a very indirect measure. Currently, in a follow-up research, I'm looking into ways in which to select a subset of the evaluation suite. If you're interested in any of this research, this structured dataset is available on Hugging Face. This concludes our journey into the quality and quantity of references for machine translation evaluation. Naturally, we aren't the first people to look into this, and there is a lot of related work which we'll talk about in the paper. Thanks for watching.